Okay, so welcome back. Good evening. Um, we are in the sixth week of TA live sessions for AI KRR, and today we're going to discuss some questions from week 6 content of the course. And yeah, without further ado, let's get started. But before that, can you just confirm whether my voice is clear and is my screen visible? Okay, thanks for confirming. Okay, so let's continue. Before we move on to the questions from week 6, there was a doubt raised yesterday about this particular question from um, the previous graded assignments, where we had to use resolution method to derive all possible resolvents for knowledge base 1. And so I didn't get enough time to try to solve it, but I partially tried to solve it. And there was a confusion on whether why this false is in the list of resolvents, or is in the list of resolvents. And as of now it looks like to me it's because that the knowledge base is inconsistent. There will be a false that will be occurring in the resolvents, but that is what I am thinking as of now. But give me some more time, and then I can finalize like the full complete solution, and then present it to you, maybe today at the end of the session, or maybe next in the next session itself. So yeah, as of now the inkling that I have is that this false comes up because this knowledge base is inconsistent, but I need to confirm that, and I'll get back to you on that soon.
Sir, can you just repeat once, sir? The false bottom is because of?
Because the knowledge base is inconsistent.
Okay, okay, sir. Okay.
That's what I'm feeling right now, but I haven't completely solved it. So yeah, maybe I'll confirm that once I have fully solved it, and I'm sure about my solution as well.
Okay, okay. Thank you so much, sir.
Okay. So yeah, for now let's get back to the week 6 questions, and yeah, without any further delay, let's get started. So the first question is just in front of you. This question says that select the correct statements about horn clauses. Okay, so a brief refresher on what horn clauses are. So a horn clause is basically a clause with at most one positive literal. Okay, and so there are two parts of this definition. First is that it should be a clause. Okay, and it should have at most one positive literal. That will make it a horn clause. An example is something like this, where you have a number of literals, and P, Q, R, S both have negations in front of them, and that in the sense that they are negative literals, whereas T is the only one positive literal. Okay, so they can be at most one positive literal, so which means they can be 0 or one positive literal in the horn clause. With that definition in mind, which of these options do you think would be correct?
Option A.
Okay, so there's one vote for option A, but let me go back to the definition of horn clauses. It should be a clause. Okay, a
Yeah.
clause is connected
Disjunct.
by ors, not ands. That's right. So it should be a disjunction, not a conjunction. Okay, now what do you think? Would A and B be correct?
C. C.
C, yes, C seems to make sense. It's a disjunction of literals with at most one positive literal and 0 or more negative literals. Now, what about option D?
D is also right, sir, I think.
Yes, D is also correct.
D is also right, because horn clauses should satisfy the definition of a clause in CNF formula, because by definition, a horn clause should be a clause. And then what about the last option?
No, it's false.
Okay, think
True,
about it.
sir, true.
Yeah, it will also be true, because when we write this as logical implication, so if you remember, implication can be written as P implies Q can be written as not of P or Q,
Conjunction key.
right? So if you have something like this, you can rewrite this as an implication, right? So this first statement over here can be rewritten in this way, where the first part becomes the conjunction of all the supposedly negative literals, and then this implies the positive literal. So option E is also correct. It can be written as a logical implication, have a head and a body, where the head has at most one positive literal and the body is a conjunction of 0 or more positive literals. Okay, so the correct options are C, D and E. Okay, this was straightforward. Let's move on to the next question then. This question is also based on horn clauses, but this tells us that this asks us which of the following can be expressed as a set of horn clauses, and we have to use the rules of substitution to convert them to clause form. Okay, so these we have to simplify these options, and then after simplification we have to tell which of these fit in the definition of horn clauses. So I'll let the screen be here for a while and I'll let you try to work through the solutions, and after a couple of minutes we can have a look at the detailed stepwise solution and see which of these options are correct.
Option A and B.
Okay, we have vote for options A and B. Let's go through the solutions and see which of these are actually correct. Okay, so first thing that we need to do is to simplify these things. Okay, and let's start with this one, option A first. So here we have for all x, teen x and there exists y, owns x comma y and apple y implies happy x, which basically means that for all variables x, if x is a teen and there exists a y such that um, x owns something called y and that y is supposed to be an apple, that makes the person x happy. It sounds complicated, but it's a simple statement. Okay, so let's simplify that. The first thing that we're going to do is to simplify this implication operator over here. Maybe let me use yeah, I think that is better. Yeah, so let's try to remove this implication first, and this we can do by negation of, so P implies Q can be replaced by not of P or Q, right? So there will be a negation in front of this whole thing, or happy comma x, sorry, happy of x, and then we'll push this negation inside, right? So this will have not of teen x and will be converted to or. This there will be a negation of there exists y, right? By the way, can you see my cursor when I'm moving it?
Yes, sir.
Okay.
Visible.
Okay, great, great. Yeah, so we'll keep pushing the negation inside, and this is where we end up at this third step as of now. And this negation of there exists y will be converted to for all y, a universal quantifier, and then the negation will be we will keep pushing the negation inwards. So this will then be converted to not of owns x comma y. This and will be converted to or. Then we'll have a negation in front of apple y, and then all these parentheses will be removed in the end. And in the end, we will have we will push this universal quantifier towards the left hand side over here, and finally we have something like this. We have not of teen x, or not of owns x comma y, or not of apple y, or happy x. So does this fit into the definition of a horn clause?
Yes, sir.
Yes, it does, right? Because we have 1, 2, 3 negative literals and one positive literal, which is happy x, and all these are connected by or operator. So it's a disjunction, it's a clause, and it contains at most one positive literal. So this is a horn clause. Now let's have a look at option B. We will similarly simplify option B. Okay, we'll first remove the implication from here. That will give us the negation in front of here, and then this will be replaced by an or operator, and then we'll keep pushing the negation inwards to finally obtain this particular simplification, where we have for all x, for all y, not of teen x, or not of x comma owns x comma y, or not of apple y, or happy comma x, sorry, or happy x, or not of attentive x. So is this in clause horn clause form?
Yes, sir.
Right, it is still in horn clause, because again we have 1, 2, 3 and 4 negative literals, and one at most one positive literal, which is happy x. So B is also in horn clause form. Let's look at option C and D. Again, you can go through the derivation or the simplification. I'll leave it on here for a while, but eventually in option C you will arrive at this form where we have 1, 2, 3 negative literals in one part, and then one positive literal in the first part. Then we have a second part as well over here, where we have again 1, 2 and 3 negative literals, and at most one positive literal. So together this whole thing is also in the formation of a horn clause. Okay, because this part is a horn clause, and then this part is also a horn clause. So together they are also horn clauses. So option C is also falling into the definition of horn clause.
Sir, I have a doubt, sir.
Yeah.
So in the first part, assume there is a positive literal, and in the second part, there is no positive literal.
Hmm.
Will that not be a horn clause, sir?
In the second part, you say that there will be no. So, if
Yes.
you remove this proud you, right?
Yes, if there is no positive literal, will this statement not be a horn clause?
So the definition says that there should be at most one positive literal. At most meaning that there could be one or less than one positive literals, right? So even if there are no positive literals, we can still say that it is a horn clause if it does satisfy the conditions of a clause. Does that make sense?
Yes, sir.
Only if there are more than one positive literals, then we are running into a problem.
Okay.
Which is what actually we will see in the last option, option D over here. So when we simplify this particular option, we will arrive at some kind of notation that is like this, where we have 1, 2, 3 negative literals, and then 2 positive literals. Okay, so this is not falling into the definition of horn clause. So this is not a horn clause.
Got it, sir.
Okay, so the correct options would be A, B and C. Okay, so maybe I'll just leave this option C and D here for a while so that you can have a look. Options A and B are also similar but simpler than option C and D. You can have a look at this and convince yourselves for a couple of minutes. Then we'll move on to the next question. Okay, maybe we can move on to the next question then. So now we are entering into the territory of Prolog. Okay, so Prolog is a programming language, and you can install it on your own system if you have. Yeah, if you want, you can install it on your own system, or if you don't want to, you can use it in online version. There's an online version of SWI Prolog as well. If you just do a Google search, you can find it, and I would encourage that you do that so that it will be easy for you to practice as well as understand the questions in the question that we are going to discuss, or the question that are there in the practice assignments, as well as the questions that are there in the graded assignments. Okay, so yeah, so let's start with the questions. And so I won't be showing the actual implementation in Prolog. I will be showing screenshots from the actual implementation in Prolog, and hopefully that will help. Let's get started. So the third question says that each option below has a pair of predicates expressed in SWI Prolog. Okay, and we have to identify which of the pairs are unifiable. So this question urges us to use SWI Prolog to investigate term unification. So if you have Prolog with you, you can do that. If you don't, um, you can install it later on and test it out. But for now, just think of unification that we studied in the previous weeks and see which of these can actually be unified in a proper sense. Okay, so I'll leave this question here for a couple of minutes and then we can discuss the solution. Okay, so any partial solutions or any guesses on which of these could be unifiable?
B.
Okay,
This
we have one vote for option B. Um,
that one is
what about option C and D? So it's clear that A will not be unifiable because we have on the left hand side we have a constant, on the right hand side we also have a constant. We cannot replace we can replace a constant with a constant only if they are exactly the same, right? So A will not be unifiable. B will be unifiable because on the left hand side we have x, which is a variable, and on the right hand side we have star earth, which is kind of a constant, and we can replace x with star earth, and that will make it unifiable. What about option C?
if you will take x is equal to 1,
That's
y
right.
is equal to 2 star 3,
That's right.
then f of z, y is equal to f of z. Now y is the 2 star 3, na? Then y just 3.
So let's have a look at the solution. and see whether our thinking process is in the right direction. Okay, so this is how you can test it in Prolog. Basically, you enter p comma sun equals p star comma earth, star earth, okay, and then you end it with a full stop, and then you press enter. This will give you false. This means that it is not unifiable. In case it is unifiable, which is option B, it will give you a possible solution. Okay, so here this assigns x to x as star earth. Okay, this is one possible solution, and this is unifiable. Again, if you test option C, you will see that Prolog returns false. And
False.
why that is the case is because, so here we will try to equate each of these terms on the left hand side to the right hand side. Okay, so the first term is x plus y on the left hand side, on the right hand side is 1 plus 2 into 3. So we want to equate x plus y to 1 plus 2 into 3. We can easily replace x with 1, and we'll have to replace y with 2 into 3.
Yes.
Okay, this will be the first set of assignments. Then we will have to equate f of z with y. Okay, let's say that we do that. Let's say fz equals y. Okay, but then in the third step we again said that z equals to y into 4 from here, this and this. Do you agree with me?
Yeah.
Do you see the problem here?
Yeah. Cannot find the solution.
Yeah, so the issue here is that this is a cyclical definition. So we
Yeah.
have f of z that is defined by y, and then z is also defined by y into 4, right? So this kind of results in some issues, and because of that the Prolog system cannot do a proper unification. Yeah, so I hope this was clear. If we look at the third option, then if you look at the fourth option, then we will see that there is a proper one-to-one mapping of the different substitutions that we can make. Okay, for example, here x plus y can be replaced with 1 plus 2 into 3. So x takes 1, y takes 2 into 3. F of y is equals to z, um, and so z becomes f of 2 into 3 because y is 2 into 3, and then z becomes f of u into v, where u is 2 and v is 3. So there is a proper one-to-one mapping, and this is what Prolog will return to us. Okay, and this also says that option 4 is unifiable. So if we go back, so B and D are the correct options in this case, and I would highly encourage that you test it out yourself using Prolog so that you can get more accustomed to the framework and how Prolog works. Okay. Okay, then let's move on to the next question. Sorry.
Sir, I have a query.
Yeah.
Sir, testing in the Prolog, sometimes if the Prolog, rather than mapping the value, just if it is giving, whether it is true or false, then can we say that they are unified?
Shyam, your voice was breaking slightly, but I think the question that you're asking was that can we do it without using Prolog? Is that right?
No, sir. No, sir.
Then?
Sir, am I audible, sir?
Yeah, now it's clear.
Okay. I'm asking, like, when we are using these formulas and testing in Prolog, sometimes like the Prolog is giving, rather than mapping, it is giving a result as true or false. So in that case, can we comment anything on whether it is unifiable or not?
Yeah, when it is giving false, it means that it is not unifiable, right? When it is giving values as substitutions that you can make, that means that it is unifiable.
No, sir. Actually, like for some of the cases when I have tested, it is giving true, sir. For some values, it is giving, and some values it is giving false. And so for true value, I didn't find any mapping.
So in that case, maybe you have to check whether the inputs you have given is correct or not. If you put the input in this particular format, the way it is given over here or here, you should get either a false or a set of substitutions. Okay.
Okay. Okay,
Maybe,
sir. I'll
yeah,
recheck it again.
maybe recheck that, and I think that should solve the issue.
Okay, okay, sir. And actually, like I think so in the practice assignment, you have mentioned like you have given steps by using command prompt, right? You asked us to install, like there was an instruction to install SWR Prolog and run it in command prompt, right?
Yeah, this is a command
So
prompt itself.
yes, sir. I think, I mean, directly running the GUI, like I have tried running directly from the Pro, whatever the software I have installed. I think that is more convenient, sir, because consult and when we press new, automatically some new file is, I mean, new file is automatically created. So we can directly copy paste the code and we can run.
That's fine. That is up to you. I mean, whichever method you find more convenient, either through command line or through writing a new script, whatever works for
Yeah.
you. Yeah, there's no set
Command
rule on
line,
that.
like, we have to create a text file and we have to name it .pl, but there it is automatically happening. Directly, if we double click that prologue shortcut and do everything is, I mean, there are some steps has been cut short.
Sure,
So
sure. If that works,
I
then
think,
you can follow that.
yes, sir. Yes, sir. You can go ahead, sir.
Okay. So this fourth question tells us that the prologue. So we are given a prologue program. Okay, and it defines natural numbers using 0 and a successor function. So successor function in prologue is nothing but plus 1. Okay. So for example, if x is a natural number, s of x is nothing but x plus 1. Okay, and we define three different versions of a less than predicate. Okay, so we want to check whether less than, if we are given less than x comma y, we want to check whether x is less than y. Okay, and we define this function in three ways. The three of the ways are given by less than 1, less than 2, and less than 3. Okay, each of these have a base case and then a formal definition. You can think of this particular statement over here, this colon followed by a dash, this is basically if in prologue. Okay, so for example, what this first two lines mean is that 0 is a natural number. Okay, that is what is meant by nat 0, and then nat sx colon dash nat x full stop. This basically means that nat s of x, which is successor of x, is a natural number if x is a natural number. Okay, which basically means that x plus 1 is a natural number if x is a natural number. Okay, that is what is meant by the statements over here. And then you have different definitions of less than in three different ways: less than 1, less than 2, less than 3. And we have to decide which of these are the correct definitions of less than. Okay, and the way you can test that is by taking some very simple test cases. For example, I'll suggest you try two test cases. First, check whether 1 is less than 2, and then check whether 2 is less than 1. Okay, and checking these two test cases should give you an idea of which of these functions is correctly defined. So I'll let you think about it for a couple of minutes, and then we can discuss the solutions. Okay, maybe let's try to see which of these options are correct. Okay, and so when you test these two things in Prolog, you will put commands like this. So first you have to give the definitions, okay, of the three definitions of the less than functions, and then you can test it using less than 1 s0, which is 1, and then ss0, which is 2. Okay, so successor of 0, which is 1, successor of 0, which is successor of 1, which is 2. Okay, this is how you test 1 is less than 2 and 2 is less than 1. Now let's look at each of the definitions one by one and test each of these cases. First, let's take 1 less than 2. Okay, so let's say x is 1, y is 2. Okay, so less than 3 says that 0 is less than anything, okay, which is making sense. And then we have successor of x, which is 2, is less than successor of y, which is 3, if 1 is less than 2. Okay, so this checks whether 1 is less than 2. This seems to make sense, no contradictions as of now. Now let's have a look at the second one, which is where x takes the value 2 and y takes the value 1. Okay, here successor of x becomes 3, successor of y becomes 2. So this will tell us if 2 is less than 1, which is not, then 3 will be less than 2, which again will be false because 2 is not less than 1. Okay, so this definition also checks whether 2 is less than 1 or not. Now let's have a look at less than the definition 2, which is less than 2. Here let's give x value 1 and y 2. So this becomes then 1 is less than successor of 2, which is 3. So this says that if 1 is less than 2, then 1 is less than 3. So far so good. Now let's test the other condition, which is 2 less than 1. So x takes 2, y takes 1. In that case, over here we will have x is 2 and then successor of y will be 2. So this says that 2 is less than 2 if 2 is less than 1. Does this make sense?
No.
No, right? This doesn't make sense, which means that there is something wrong with this definition. So less than 2 seems to be a wrong definition. Now let's check less than 1. Again, let's put 1 over here and 2 over here. So if 1 is successor of x, then x must be 0, right? And then y will be 2. So this tells us that 0 less than 2 if 1 less than 2.
Yeah, correct.
As of now makes sense, but let's check the other one. So here, sorry, s of x is 2 and y is 1. S of x is 2 means that x is 1 and then y is also 1. So this tells us that 1 less than 1 if 2 is less than 1. Does that make any sense?
No.
No, right? So this means that there is something wrong with the definition of less than 1 as well. So what you can conclude from over here is that this is not a correct definition. This is not a correct definition. This, though, seems like a sensible definition, and so less than 3 is what we will say is the correct definition of the less than predicate. Okay, so this is how you can test in Prolog using very simple test cases if you are asked these kind of questions. Okay, shall we move on to the next question then?
Sir, how less than 3 is correct?
Because we checked both the cases, 1 less than 2 and 2 less than 3, and both of those didn't encounter any difficulties.
1 less than 2 and 2 less than 1. Na?
Yeah. So when we test for 2 less than 1, it will say that 2 is not less than 1 as per the definition. So here x would have taken 2, y would have taken 1, s of x would be 3 and s of y would be 2. So 3 less than 2 if 2 less than 1, but 2 is not less than 1, right? So this will return false and then this will also return false. So this will check correctly whether 2 is less than 1 or not.
Yeah.
So these are some a simple example that you could check with. There can be other examples also that you can make the tests with. Okay. Um, any thorough example that helps you test the correctness of a definition should work. Okay, then
Okay.
let's move to the fifth question. So this is again based on prologue, and here we are given four predicates P, Q, R, and S. Okay, we have to select the predicate that defines the length of a list as a number n. So if you think of it in terms of programming, this is essentially a predicate which takes as input the list containing certain elements, and then it should return a number n that defines the number of elements in that list. Okay, and we have four candidate predicates that we have defined that could give us the actual value of n when we give as input a particular list, but we have to select which of these are correct definitions or correct implementations of this question that or the problem that we want to solve. Okay, so I'll let you try to go through the different definitions that we have, and I'll urge you to emphasize on how we are calculating the value of n. So there are a few variants. Some of them have used this is operator over here, and some of these have used the equal to over here. So if you test this in Prolog, you will see that both of these result in different outputs. For example, if you do x is something plus something in Prolog, you will get something else. If you do x equal to something plus something, you will get something else. Okay, so I urge you to test that, and then you try to understand which of these would be the correct definition of the problem that we are trying to solve, and then we can have a look at the solution.
I think B, sir.
Okay, so we have a couple of votes for some options. I'll give you a hint. Only one of these is correct. One of the options is correct. And again, I'll urge you to understand the difference between using the is operator versus the equal to operator. Okay. Okay, so one thing that I'd like to draw your attention to is when you do something like x is 1 plus 2 full stop in prologue. Ideally it should give you x equals 3. Okay, but then I'll urge you to check it out yourself. It should give you this, not 31, it should be 3. But if you if you give x equal to 1 plus 2 in prologue, it will output x equals 1 plus 2, not the actual sum. Okay, again I'll urge you to check it out yourself, but this is a basic difference between using is and equal to, and that will differentiate which of these predicates is the correct definition. Okay, so let's say we give an example list 10, 20, 30, 40 that contains 4 elements. Okay, and what this will do is, so the definition tells us that the base condition is that empty list has length 0. This makes sense?
Yeah.
Yes, sir.
And then recursively we define the length of a list in this manner. Okay, let me write it on the side over here. So firstly we can represent a list as follows. The list can be divided in 2 parts, which is the head and the tail of the list. Okay, for example, if we have this 10, 20, 30, 40, then 10 would be the head part of the list, and then 20, 30, 40 would be the tail part of that list. Okay, if this is clear, then let's have a look at the definition now. The first definition tells us that a list represented in the form of head and tails has length n if a list containing only the tail part of the original list has length m and n is m plus 1. Is this definition clear?
Once more, sir.
Okay, so basically what this tells is, let me take this list itself. So this tells us that this list represented in the form of, let me just use 1, 2, 3, 4 instead of 20, 20, 30, 40. Okay, 1, 2, 3, 4, where head is 1 and 2, 3, 4 is the tail. This has length n if 2, 3, 4 has length m and n is m plus 1. Okay, this 1 coming from the head element that we removed. Is it clear till this point?
Yes, sir.
Okay, now is there any question? Okay, maybe not. So yeah, so now we will try to recursively solve for m. Okay, so 2, 3, 4, where head is represented by 2 and tail is 3, 4, has length m if, sorry about that, if 3, 4 has length say x and m is x plus 1. Does it make sense?
So why we have written m is x plus 1? Why?
So what we are doing essentially is we are removing one element at a time from the head of the list, right?
Yeah.
So when we say that the length of this original list is, let's say, n,
Yeah.
This n should be equal to length of the tail part of that list plus 1, right? Because 1 corresponding to the head element that we will remove in the next step.
Okay.
Does that make sense?
Yeah, yeah.
Similarly, in the next step, we say that if 2, 3, 4 has length m, then um, then m should be the length of this tail part alone, 3 comma 4 plus 1, which is corresponding to this 2 over here.
Okay.
Okay, so if we continue doing this recursion, now we will have the length of 3 comma 4 is x. So here now 3 will be the head now. If the length of this list 4 is y and x is
Y plus 1.
y plus 1, exactly. And when we further recurse this, here the head element will be just 4 and tail will be nothing, empty list. So empty list has length z and y is z
Z
Z
plus.
plus.
plus 1.
Yes. Now we have reached the base case, right? We know that
Yeah.
the length of an empty list is 0. So z will become 0, y will become 1, x will become y plus 1 2,
2.
m will become 2 plus 1 3,
3.
and n will become 3 plus 1 4. So that's how we get the value of n as 4. Okay, so this is what is written over here as well. So when you save this definitions in Prolog and then try to run this particular command, you will see that Prolog returns n equals to 4. Okay, but when you test the second definition, when you use equal to, instead of computing the sum, it will give the output in this format, which is not what we want. We want the actual value of the length of the list, not 0 plus 1 plus 1 plus 1 plus 1. This is also equal to 4 only, but we don't want to output this. We want the correct value of the length of the list. That's why q is not the correct definition. Does that make sense?
Yeah.
Yes, sir.
Similarly, R and S are also not the correct choices over here, because what R is doing is, instead of adding 1 whenever we remove the head of the list, we are adding the value of the head itself. So instead of calculating the number of elements, it is in fact calculating the sum of all the elements. Do you agree with me?
Yeah.
So this is doing 40 plus 30, which is 70, plus 20, which is 90, plus 10, which is 100, and that is what it is returning. And similarly, this for the last definition again, which again uses an equal to operator, this again gives this output, which is not what we want, right? So this predicate p is the only one that gives us the length of a list n, length of a list l as n, right? So the correct option would be option A. Is that clear?
Yes, sir.
Yes, sir.
Okay, if that is clear, then what do you think would be the correct answer for option 6? So it's the same set of predicates that we have. Now we have to select the predicate that correctly calculates the sum of all elements in the list L as a number n. So which of these definitions do you think would be doing that correctly? So I'll once again show the outputs of the prologue. Which of these do you think would be the correct definition?
C option C.
C1? This one, right?
Yeah.
Any doubts on that?
No, sir.
Okay, that's great then, and it is in fact correct. So the R predicate would be the correct one. Okay, then let's move on to the next set of questions. So the questions from 7 to 11 will be based on this data that we are given. Okay, so first we have defined some predicates over here. Okay, same as a comma b. This basically tests whether lists a and b are the same or equal or not. Okay, and this list could contain numerals as well as alphabets. They have to be exactly the same, only then the same as should return true. Okay, and then you have prefix of a comma b, which says whether list a is a prefix of list b or not. For example, this 1 comma 2 is a prefix of this larger list 1 2 cd5. Prefix meaning it occurs at the front. Okay, then we have another predicate
So
suffix of.
screen is not visible.
Okay, sorry about that. Is it visible now?
Yes, sir. Sir,
Yeah.
once more, sir.
Yeah, so I'll just repeat. So we are given different predicates over here, and I'll just go through the definitions of each of them. So the first one says that same as a comma b, which basically should tell us whether lists a and b are the same or not. And for them to be the same, they have to be exactly same as each other, equal to each other. So this list can include both numbers as well as alphabets. Okay, if they are exactly the same, then with the same as will output true. Okay, then we have prefix of a comma b. This will tell us whether a list a is a prefix of list b or not. For example, here 1 comma 2 is a prefix of this larger list 1 2 cd5. Okay, prefix meaning it occurs at the front of the list. Similarly, suffix of tells us whether list a is a suffix of list b or not. Suffix again meaning it occurs at the back of the larger list. So d comma 5 occurs at the back of this larger list 1 2 cd5. So this is a suffix. Sublist tells us whether list a is contained in the list b as a contiguous block. Okay, for example, 2 comma c is occurring somewhere in the middle of 1 2 cd5. So 2 comma c is a sub list of the larger list b. Subsequence, on the other hand, tells us whether the elements in list a are contained in either a contiguous or non-contiguous in form manner in list b. For example, this 2 comma d is occurring in the same order in this larger list. Okay, so first we have 1, then we have 2, then we have c, then we have d, and then we have 5. So 2 is occurring first and then d is occurring. So 2 comma d is occurring in the same order in this larger list. So 2 comma d is a subsequence of the larger list. So are the definitions clear of these 5 different predicates?
Okay, sir.
Okay, so if these are clear, then what we have to do in the next few questions is we have to fill in the blanks to write the correct definition in terms of prologue for these 5 different predicates given to us. Okay, for example, the first one says that it has 2 lines of definition. The first line is a base case which says that an empty list is equal to an empty list. That makes sense, right?
So in which question are we, sir? Because
Sorry,
the screen is again in some other place.
is the screen not visible?
No, screen is visible, sir. But we are in data for question 7 to 11 in that page, that slide.
Yeah, I'm talking about that itself. So look at lines 1 and 2 over here. Should I zoom in a bit?
No, sir. No.
So basically we have to fill in the blank in this line 2 over here to complete the definition of same as. That is the first task that we have to do. That is question 7 as well.
Same means A or AS, A or BS.
Yes. So the base condition says that an empty list is equal to an empty list. Is that making sense? Which is line
Yeah.
1 over here.
So right hand side also A or AS or A or BS.
Yes, then in the definition, recursive definition, we have to check whether this list defined by A and AS, where A is the head of this A comma
Yes.
AS list, AS is the tail, and then A comma BS, where again A is the head and BS is the tail. These two lists will be equal if what will happen?
No.
Let me maybe write it down, that will make it clearer. Let's say over here.
Sir, if you don't mind, can you tell again, sir, like not clear regarding that suffix and prefix? I mean, I understood that what is suffix and what is prefix. So can you explain in terms of that code?
Yeah, that's what we're going to do. So let's look at same as first.
Yes.
So let's consider two lists. Okay, the first list is 1, 2, and let's say C. Okay, and the second list is 1, 2, D. Okay, is this much clear?
Yeah.
Now what we want to do is we want to compare these two lists with each other. And how we can do that? So Prolog gives us the ability to test the head element one at a time. Okay, so what will be the head element of the first list?
1.
1, right?
Yeah.
This is where we draw the head and this is the tail. And similarly for the second list,
1 is the head.
so let's say A represents the head, AS represents the tail.
Yeah.
Similarly here A represents the head, BS represents the tail. If they have to be same to each other, the head element must be the same, right?
Yeah.
So 1 comma 2 comma C will be same as 1 comma 2 comma D if,
If
let me write it as same as, so same as I'm writing at SA. Okay, I'm not writing the full thing. Same as 1 comma 2 comma C comma 1 comma 2 comma D if same as the sublists, right? Do you agree with me? These two bigger lists will be the same as each other if we remove the head element of these two and whatever is remaining in the tail is also equal. Does that make sense? Um, any
Sir, actually,
queries?
C and D are like some arbitrary constants, right?
Yeah, there are
Can we?
some arbitrary constant. Don't worry about what they are. We just need to see whether they are equal or not.
Okay, okay, sir. So, okay, understood, sir. So, because as per unification rules, like list will be equal to list if each element is equal to each other, right?
Yes, but here let's think of it. Okay, let me actually try to solve it from the bottom up instead of top down. Maybe that will give you some intuition. So let's say we
Okay.
have two lists which are empty lists. Okay, these two are same as each other. That you agree, right?
Yes, sir.
Okay. Now let me add another element to this list. Let's say um, I add C here, I add D here. Are these two same now?
No.
No, right? They are not the same. Okay, now let's replace D with C.
C. Unify करना पड़ेगा. We have to unify.
No, we are not doing any unification as of now. We're just taking an example.
Okay, okay, sir.
Now let's add another element. Okay, let's say we add 2 comma C. These two will be same.
Yeah.
Yes, sir.
Similarly, 1 comma 2 comma C will be same as 1 comma 2 comma C. Right?
Yeah.
This part you agree with me, right?
Yes,
Yes,
sir.
sir.
Now let us remove everything. Now that you understand bottom up, let's try to do it top down. We have two lists, 1 comma 2 comma C and 1 comma 2 comma D. Prolog wants to test whether these two are same or not, right? So how it can do that? It will start examining the elements from left to right. Okay.
Yeah.
What will be the first element in both the lists?
1.
1.
1, right? And how can we access that?
Head part.
Using the head, right? If we write this list in the form of head comma tail, we can say that 1 will be the head of the list and 2 comma C will be the tail of the list. Similarly here also 1 will be the head and 2 comma D will be the tail. This only, instead of writing as H and T, we are writing as A and AS. Okay, so 1 is the head, which is A, and rest of the tail is given by AS. Here again head is A and tail is BS. The reason we are writing A as the head for both, because we want to check whether the list is exactly same as each other or not. And if they have to be same as each other, the basic condition is that at least the first element should be the same as each other. Only then we can move on to the second and third element and compare them and see whether they are same as each other or not. Does that make sense?
Clear, sir. Clear, sir.
Okay. So now that we have checked that the head element of the two lists are the same, we are to compare the tail of the two lists, which is 2 comma C and 2 comma D, right? Now how will we go about comparing them?
Now again head and tail part.
Head is 2, sir.
Head
Yes.
Then
is
tail
2,
with
tail is 3.
Again head is 2,
2,
tail
tail
is
is C.
tail is
C.
C. Again head is 2, tail is
D.
D. So again we see that the head of this list is the same. Now we will go on to compare the tail, which is C and D.
D.
Sorry about that. What will be the head in this now?
C.
C will be the head, that is right. And the tail will be an empty list because there
intelligence.
is nothing after C, right?
Yeah.
Similarly here we will have head as A and the tail will be an empty
Empty
list.
list.
Okay. Again we will compare the head elements, but now here the head elements don't match, right?
Yes, sir.
So prolog will tell us that because at some point the two elements in the list did not match, which means that the list is not exactly the same as the other one. So eventually it will return false. So have you understood the working now?
Yes, sir.
Yes, sir.
Understood.
Now if we go back to the definition, is this now clear? So if we
Yes,
have to
sir.
say that two lists are equal to each other, 1 to C is equal to 1 to D if 2C is equal to 2D,
Yes, sir.
or same as A comma AS and A comma BS
BS.
if same as
S of AS comma BS.
exactly. So this completes the definition that we wanted to get, right? This will form the correct definition of same as. Let's look at the question. Here we are just asked to fill in what will be the blank in line 2, and that is actually same as AS comma BS. So is this much clear?
Yes, sir.
Okay, now that same as is clear, now we have to similarly fill in the blank for prefix of. Let me go back to the definition that we had here. Lines 3 and 4 is what we have to focus on. Okay, the base case tells us that empty list is a prefix of any list. That makes sense? Prefix meaning that something that occurs at the front of the list. Okay,
Okay,
so
sir.
empty list is at the front of any list, right?
Yes, sir.
If we put empty as head and all of the other things as tail, then empty list will become the prefix, right?
Yes, sir.
That is the base case. And then the recursive definition says that list represented by A and AS, comma A and BS. So A and AS will be a prefix of A and BS if what will be the blank here? See, remember prefix means something that occurs at the front of the list. So if let's say we want to check whether 1 comma 2 is a prefix of 1 comma 2 comma C comma D comma 5 over here, right, where my cursor is pointing,
Yes, sir.
we need to keep on comparing the one element at a time of the first list with the elements of the second list. And if we arrive at a situation where we have exhausted the elements of the first list and we still have elements remaining in the second list, then we can say that the first list is a prefix of the second list. Do you agree with me?
Yes, sir.
So
No.
based on, okay, let me go over it once more. So let's say we want to compare 1 comma 2 with 1 comma 2 comma C comma D comma 5. Okay, here what will be the head of the first list?
1.
1, and that of the second list,
1.
1.
that is matching, right?
Yeah.
Now what will we compare?
And then tail part.
1 comma 2.
Tail part.
2.
So 2 with 2 comma C comma D comma 5,
5.
right?
Yeah.
What will be the head in that case?
2.
2. That will also match with the head of the second list, which is 2.
Yes,
2.
sir.
Yes.
Yes,
Okay,
sir.
now what do we have remaining in the first list when we have exhausted both 1 and 2?
Empty
Empty
list.
list.
Empty list. Okay,
Yeah.
now
Yeah.
based on the base condition given to us, empty list is a prefix of any list, right?
Prefix. Empty
Prefix,
list is the prefix. Huh.
right? So
Yeah.
now based on that, what do you think will be the blank over here in line 4?
It is a CD5.
CD5, that is fine, but that is an example. But if we have to
Yeah.
put in the definition over here, we can say
Okay, that
that
is the tail part. BS. BS.
yes, we have to compare whether AS is a prefix of BS,
The BS.
right?
Yeah.
Is everyone convinced of that?
Yes, sir.
Okay, so that is actually the answer that we want to look for, um, which is prefix of AS comma BS. Okay, now let's look at suffix of. Okay, let me go back to the definition that we had. So here we are actually given the recursive definition, we have to come up with the base condition. Okay, so the recursive definition tells us that AS is a suffix of b comma bs, where b is the head of the second list and bs is the tail of the second list, if as is also the suffix of bs. So suffix is just the opposite of prefix, in the sense that suffix is something that is present towards the end of the list. Okay. So what we are doing over here in the second definition, so focus on line 6 alone. Okay. What are we doing recursively over here? We are checking whether this first list, which is as, is a suffix of b comma bs, where b is the head and bs is the tail of the second list. Do you agree with me?
Sir, can you like initially you have done right, like similarly can you explain with some numericals, sir? I think it will be clear.
Okay, fine. So here let's look at this example, d comma 5 and 1 comma 2 comma c comma d comma 5.
Yeah.
Okay, so we want to check whether as represents d comma 5. Okay, whether this is a suffix of this larger list, which is 1 comma 2 comma c comma d comma 5. Okay,
Mm.
this part is clear.
Yes. Yes, sir.
Now what we want to do in this line 6 is, what is the head element of the second list?
1.
1. The definition in line 6 tells us that d comma 5 is a suffix of 1 comma 2 comma c comma d comma 5 if d comma 5 is also a suffix of 2 comma c comma d comma 5.
Yes, this is the suffix.
Does that make sense?
Yes.
Yes, sir.
Now again, what is the head of the second list?
2.
2. Again you will remove
Okay.
2 and you will check
Mm.
whether d comma 5 is a suffix of c comma d comma
This
5.
should be yes, it does make sense.
And then if you remove c, you have to check whether
C.
d comma 5 is a suffix of d comma 5. How will you
Yes.
check that? You can reuse one of these predicates we defined earlier.
Right.
So as is a
Okay.
suffix of bx if they both are the same, right?
Yeah. Same as S. It's same as ARS. Same as ASBS.
Yes. So here the blank 5 will be filled with same as as comma bs. Is this clear?
Yes, sir.
Okay, that's great. Now we go to sublist. Okay, again here also we have to fill in the base condition. We are given the recursive definition in line 8. So again, remember in sublist we need to have a contiguous block. Okay, so let's take this example, 2 comma c and 1 comma 2 comma c comma d comma 5. Okay, so what is the head of the first list?
1,
No, the first list, 2 comma c.
2.
2, yeah.
Yeah,
Eh,
2 is the head of the first list
yes, yes, yes.
and the head of the second list is 1, right?
1, yes.
These two are not the same, right? Which
Yeah.
means that the sublist does not start from here if it exists at all. Do you agree with me?
Yes, sir.
So now we will do away with the first element of the larger list and we will compare 2 comma c with the remaining list, which is 2 comma c comma d comma 5. Does that make sense?
1 second, sir.
Okay, so let me write it down again. So we have 2 comma c and 1 comma 2 comma c comma d comma 5. Okay, the head of the first list was 1 this is not equal to the head of the head of the second list was 1, which is not equal to the head of the first list, which is 2, right?
Yes.
Which means
Yes,
that
sir.
the sublist does not start at the first position. Do you agree with that point?
Yeah.
So then we have to compare 2 comma c with the rest of the second list, which is the tail of the second list, 2 comma c comma d comma 5,
Okay.
right? Do you agree with me?
Okay, sir.
Others? Any doubts here?
No, sir.
Okay. So how will you check whether 2 comma c is a sublist of 2 comma c comma d comma 5? What is the easiest way to do that? Given the predicates that we have defined till now, we have defined same as, we have defined prefix, and we have defined suffix.
Prefix. This is the
So
prefix.
we can use prefix, right? 2 comma c
Yeah.
will be a sublist of this thing if 2 comma c is a prefix of this thing, right?
Yeah.
That is what is that is what we have to fill in over here in line 7. So sublist as comma bs if prefix of as comma bs, which is line 7, and then sublist a comma as and b comma bs if sublist of a comma as and bs. Does that make sense?
Sir, can you just go back to that numerical values that you explained, right?
Yeah.
Sir. Sir, actually, like one doubt is, so this I understood, but sublist can be something like d comma 5, right? It is also a sublist.
Yes. So if d comma 5 is your sublist, then we'll go for a few steps further, right? So let's say in the first list, instead of 2 comma c, you had d comma 5.
Yes, sir.
So you have d comma 5 here, and you have d comma 5 here.
And this is the suffixes.
No, we won't check the suffix as of now. We will start going from the front because sublist will occur in order, right? It's a contiguous block.
Yeah, yeah.
So when we look at the head of the original list, 1 was not matching with D. So we moved on to the tail of that list. Again, do the same thing here. Is 2 matching with the head of this initial list?
No.
No. So again, we will
Mm.
check for the tail of the remaining, the tail of the list remaining with us. So D comma 5, and what will be here?
C
C,
comma
sir.
D comma 5.
That's right. Again, we will look at the head element. C and D, are they matching?
No.
No. So again, we will compare D comma 5
D comma 5.
with D comma 5. Now D comma 5 is a prefix of D comma 5, right?
This prefix, or it is same
Sub
as it. So it may be same
Prefix,
as it.
no, prefix, which let's check for prefix, because prefix involves in its definition the use of same as, right? We just saw that. See, the difference between same as and prefix over here, the use of same as and prefix over here, is that we are trying to find a sublist. Okay, so let's
Yeah.
have a list. Let's say 1, 2, 3, 4, 5, 6. 1 comma 2 is a sublist. 2 comma 3 is a sublist. 3 comma 4 is a sublist. 4 comma 5 is a sublist. 5 comma 6 is a sublist. 1 2 3 is a sublist. 2 3 4 is a sublist. 4 5 6 is a sublist. 1 2 3 4 is a sublist. 3 4 5 6 is a sublist. 1 2 3 4 5 is a sublist. 2 3 4 5 6 is a sublist. The important point about sublists is that it has to be a continuous block going from left to right of the original list. Okay, so when we try to deduce whether something is a sublist of a larger list or not, what is the strategy that we are going to use is we are going to remove one element at a time from the front of the list if the front element does not match. So let's say we wanted to check whether 3 comma 4 is a sublist of 1 2 3 4 5 6 or not. So first we will compare the first element 1, right, which is not same as 3. So we know that sublist does not start here. Okay, so next we will compare 3 comma 4 with 2 3 4 5 6. Okay, again 2 does not match 3, so we will remove 2, and then we will check whether 3 comma 4 is a sublist of 3 4 5 6. What is the easiest way to check whether 3 comma 4 is a sublist of 3 4 5 6? It's prefix, not same as, right?
Yes, sir.
Because the two lists won't always be the same in size. So if we check 3
Hmm.
comma 4 is the prefix of 3 4 5 6, we will easily know whether 3 comma 4 is a sublist of the larger list where 1 and 2 appeared before 3 4 5 6. Do you agree
Yes,
with
sir.
that point?
Yes, sir.
Yes,
That
sir.
that's why we are using prefix over here.
Yes.
Is that clear now?
Sir, can you repeat the last line alone, sir? The last line, yeah. Some
This one.
interpretation. Yes, I know the last line which you had said.
So the last line that I said is that when you are starting to remove one element at a time from the front of the larger list, we might not always end up in a situation where the sub list is equal in length to the list that is remaining with us. Here, for example, we arrived at a situation where we had 3 4 and we were comparing that with 3 4 5 6.
Yes, sir. Yes, sir.
In this case we got lucky whereas wherein we have the sublist d comma 5, which is also in similar in same in length to the list remaining with us, which is d comma 5. In this specific case we could as well have used same as, but this won't happen all the time. So a safer route to go by is to check whether d comma 5 is a prefix of the remaining list. That will also cover the same as condition. That is what I was trying to say. So
Yes,
if
sir.
we check 3 comma 4 is a prefix of 3 4 5 6, we will have an answer to um the sublist problem that we are trying to solve. Does that make sense?
Yes, sir.
Yes, sir. I think checking both prefix of the list, I think a problem would be, I mean, like I think we have to represent in that way.
Yeah, that's right. So the blank will be filled by, the blank in line 7 will be filled by prefix of as comma bs.
Prefix of first list and prefix of
Prefix of as comma bs, right?
yes.
Okay. Now that sublist is clear, let's move on to subsequence. Subsequence is slightly tricky in the sense that now we don't necessarily want the list to be continuous, sublist to be continuous. For
Sir, can you
example,
show answer for that sublist, sir?
I mean, we will arrive at the answer, but let's not jump to the answer. Let's try to deduce it first, right?
Okay, okay. Sir.
So consider this example where we have 2 comma d and we want to check whether this is a subsequence of 1 comma 2 comma c comma d comma 5. Now based on just the definition of subsequence, do you think this is the subsequence of the larger list? Is 2 comma d a subsequence of 1 comma 2 comma c comma d comma 5? It is, right?
Yes, sir.
Okay.
Okay, can you give me an example of something that will not be a subsequence?
So if I take some elements which are not in the second list, I think that would be.
2 comma D and 1 comma 2
2
comma C
1.
or 2
2
comma
1
5.
cannot be a sequence.
Two
For
is,
sure, if we take an element that is not in the larger list, it won't be a subsequence.
yes,
But
sir.
say
1
if we take elements that are
2
in the
1.
exactly, if it is not following the order in which it is present in the original list, then also we can't say that it is a subsequence,
Sequence. Yes.
right? So instead of 2
Yes.
comma d, if we had, let's say, 2 comma 1, then also we
It
can't
cannot
say
be
that
a
it is a
sequence.
subsequence.
Yes.
Okay, so now that definition of subsequence is clear, Now let's look at the program that we have to complete. Okay, so how do we proceed here? The base case is given as empty list is a subsequence of any list. That makes sense?
Continue.
Line number 9 over here.
Yes, sir.
We have to fill in line number 10. We're also given line number 11, which says that list A comma AS is a subsequence of list B comma BS if A comma AS is a subsequence of BS. So there can be two possible conditions, right? Let's say we have two lists 2 comma D and 1 comma 2 comma C comma D comma 5. Okay, we will start comparing the first element like we did in case of sublist. Okay, so the first element 1 is not equal to the first element in the sublist is candidate sublist subsequence that is given is which is 2, right? So 1 is not equals to 2. Do you agree with me?
Yes, sir.
So then we will check whether 2 comma D is a subsequence of
2CD5.
2CD5, right? We will proceed in that manner and they will keep on going recursively. What if we had something like this? What if we wanted to check if 1 comma D is a subsequence of 1 comma 2 comma C comma D comma 5? Here the first elements match. So what will we do in the next step then?
Then D.
Exactly, that's perfect. We already know that the first element is exactly the same, so we now need to compare,
D.
yes, the rest of the elements of the candidate subsequence with the rest of the original list 2 C D and 5,
D5.
right?
Yes, sir.
These basically are the two conditions given over here. So if we observe in line 10, we are said that we are given that A comma AS is a subsequence of A comma BS. Note here that the head of both the lists, first list as well as second list, is the same. So in this case, we just have to check whether AS is a subsequence of BS. Do you agree with me?
Yes. Yes, sir.
In case the head element of the two lists is not the same, which is what is represented in line 11, A comma AS a subsequence of B comma BS? Note here that A and B are not the same. In this case, we have to check whether A comma AS is a subsequence of BS, right?
Yeah.
So what will be the blank here?
Go. The subsequence of ASBS.
That's right, subsequence of AS comma BS. Let's revisit the example that we were looking at. Here this was A, this was AS, this was A, and this was BS, right? Since we know that the head element is the same, we are just going to check whether AS is a subsequence of BS or not, right?
Yes, sir.
Yes, sir.
And in the second case, which is shown in line 11, here A was 2, AS was D. Here the head was 1, sorry, which is B, not the same as A because A is 2. And then this was BS. So we know that A and B are not the same. So now we will compare A comma AS with BS. This is what is shown in line 11.
Yes, sir.
So here in line 10, we will, when the both head elements are the same, we will just check whether AS is a subsequence of BS. Is that clear?
Yes, sir.
Any doubts there?
No, sir, it's fine.
It's
Okay,
fine.
that's great then. So if this is clear, we have covered a major chunk of the prologue questions. Okay, so we have covered question 11, and this is basically what we just discussed till now. You can go through that. Let's move on to question 12 now, which is also prologue based but slightly simpler. Okay, so along with some built-in definitions that we supply to prologue, prologue also has some in addition to some custom definitions that we supply to prologue, prologue also has some built-in definitions. For example, append is one of such built-in definition that is available in prologue. What this basically tells us that append xyz tells us that if we append y to x, we get z. Okay,
Yes.
so if you give this query in prologue, so you're giving the output to prologue. What prologue will try to do is it will try to see what are the different possible values of x and y that could give you this particular output. Okay, so basically x and y will be two lists, okay, of, and there could be multiple answers to this question. X could take different values, y could take different values. What we want is when we append y to x, which is basically we add whatever is there in y to the back of x, we should get what is given in this z part, okay, which is the total list. So if x is 2 and y is 0 2 2 0 2 2 8, will this work?
If x is 2, y is what?
Y is 0 2 2 0 2 2 8.
0 to 2. What does it mean?
So let's say if x is only, let me write it down. Let's say x is only 2
Yeah.
and y is 0 comma 2 comma 2 comma 0 comma 2 comma 2 comma 8. So when we append these two, what will we get?
Oh, 2020220228.
Right, the whole thing, right?
Yes.
2022
Zero
0
two 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 eight.
8. Now is 2 the only value that x can take? What if I said that x will take the value 2 comma 0? Then what will y take? Just this part, right? Even if we append 2 comma 0 with 2 comma 2 comma 0 comma 2 comma 2 comma 8, we get the same output, right?
Yes.
So what we want to check now, how many different possible values can x and y take so that we get the same result in the append function. And that is what we want to test using prologue, and that you can do in this manner. In the command line you ask append x comma y and the final result, right? Prologue will give you a set of values of x and y that could give you this final thing. For example, one set of values could be this, where x is empty and y is the whole list. If you append these two, you still get the full list. Do you agree?
Yes, sir.
Then we have this that we just discussed. If x is just 2 and y is 0 2 2 0 2 2 8, then also you get the whole list when you append. Do you agree?
Yes.
Similarly, when x is 2 comma 0 and y is 2 comma 2 comma 0 comma 2 comma 2 comma 8, again when you append these two, you get the same thing.
Yes.
Similarly, you see there are different sets of x comma y that give you the same total output up until the point where y is empty and x is the whole list. Even then you get the same list when you append, right?
Hmm.
So this is basically how you can
Right.
use Prolog to test what are the different values that x and y can take, so that this appended list is the same.
Oh, list plus one.
Okay. Now the question asks us, list all the solutions to the query append. Okay, what is the total number of solutions? Basically, what are the different, how many different values can x and y take? And the answer would be 9,
Yes.
because here we
List
see,
plus one.
yeah, so there were 9 such combinations, right? So there was 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, is this clear?
Sir, can you say that this is the list plus one?
Sorry.
So can you say that this is the what are the number of elements present in the list plus one?
No, okay, let's look at that. The number of elements present in the list are 1, 2, 3, 4,
Eight
5,
elements.
6, 7, 8.
8 element and one is for empty. So
That's
total is
right.
9.
That's a good observation. So we can say that. That's a good observation. So, any doubts in this question?
No, sir.
Okay, that's great. Then let's move on to the next question. So
So
now,
this total, so this total number will be coming automatically, or we need to count manually?
so if you use Prolog, Prolog will not directly give the total number. You have to count using Prolog. If you are able to write a program in Prolog that gives you the number directly, then you can get the number directly.
Okay.
Okay. Okay. So now question 30. Now we are done with Prolog. Okay. This is the last question, in fact. Question 13 asks us which of the following are the correct options, and this is based on SLD resolution. Okay. So which of these do you think are correct? All first order logic formulas can be expressed as Horn clauses. SLD resolution always terminates with a solution or a proof. SLD resolution always terminates, or none of the above. Which of these do you think is correct? Based on
None of them. None of the above.
none of the above. That's right. This is essentially a recall based question. If you have gone through the lecture slides on SLD resolution, you would know that none of the above is always true. So, yeah, that is the correct answer. And that brings us to an end of the questions from week 6. Okay, maybe this is some issue happening, but yeah. Okay, so we are also nearing towards the end of the session. Is there something quick that you would like me to discuss? I think the query about the resolution refutation is better if I take some more time and I show it in the next live session. I'm sorry for the delay, but I think I would prefer that. Other than that, is there anything else that you would like us to quickly discuss before we close the session?
This session is recorded, or what? Like, will we be getting the recorded session of this, or what?
Is
Because we
this the
missed.
first time you have joined this session?
Yes, first time I have joined.
Okay. So yeah, these sessions are usually held on Tuesday 6 to 8 p.m. and these are all recorded and these are all available on YouTube, or will be made available on YouTube
No,
as
but
the
the Excel sheet that I have seen, that is the older. I think that 2020 recorded videos are there.
no, the
So where?
Excel sheet I think is the current one. I think you might be looking at the wrong location. I'll just show the correct place where you should be looking at. So if you go to Swayam portal and if you go to problem solving session, if you use this click here link, this will lead you to this Excel sheet which has entries only till week 5 because we have had sessions till week 5. Week 6 will be filled in after today's session, and then so on and so forth for the next few weeks. Does that clarify your doubt?
Yes, but I have used again. I will check, but I have used the same link. Maybe that there was some fault from my side.
So this course has been conducted previously as well, and maybe you are checking the links from the previous iteration of the course where also similar live sessions might have been conducted. So maybe just check that. Okay.
Sir, how we put the query in the discussion forum?
For that, you can use this Q&A over here. Go to continue. That will lead you to the discussion forum. Okay. Click on new conversation and then just fill in your query. It's like sending an email. Okay.
Okay. Okay. New discussion.
Yes. New conversation. You can even check all the queries that have been asked before.
Sir, actually, like, can we expect so questions based on the prologue in final exam?
If it will be there, it will be similar to what we have discussed today. Something like something that doesn't really require you to implement something in Prolog directly. You just need to be aware of how things work in Prolog, and you can manually work it out on the sheet of paper.
Yes, sir. Actually, like today, whatever we have discussed, no, that's fine. Like you have told it in very clear and concise manner. But I think recalling those kind of like you have showed us like how to compare a list and this kind of thing. I think recalling during these things during the exam is a bit. I mean, we need practice.
Yeah, it will need practice, and I will also suggest you look into this um, um, like thing that Prolog provides. It's basically a tool that you can use, not a tool exactly, but a command that you can use to really understand what is going on inside Prolog, and it is called trace. Okay. So look up, search online about what trace is, and then use trace to understand the different programs that we have discussed in today's live session. So trace will give you the step by step follow up of what exactly goes in behind the scenes, behind the in the backstage of what Prolog does. Okay, that will help you understand how exactly things work in Prolog. So if you keep doing that, I think it'll with time it'll get really easier for you to understand.
Okay, okay, sir.
Okay, just look up what
Sir,
trace
like
is in Prolog.
how many more sessions we are going to have prologue? I think week 7 also we are having some exercise on prologue, right?
I think so. Not sure, but I definitely not more than that. I think week 8 onwards we might not have anything much of Prolog.
Oh,
Yeah, but I'm not exactly sure. Just look it up. I think yeah, till now we have only week 7. Uh,
yes, sir.
yeah, I think week 7 starts with rate net and all those things. So after week 7 there will be no Prolog.
Okay. So according to you, like what could be the future topics of this, sir? Like it is a bit difficult or it's okay, like we can
I would say that the
understand.
next few topics would be relatively easier.
Because starting like up to like week 6 was okay, sir. When you talk about prologue, it was bit okay, but up to week 5, it is. I mean, so when we talk about that resolution method, then SLD, then back chaining, so previous concepts. I mean, bit confusing. Like I mean, in the previous sessions also I have discussed, right? There is a lot of confusion kind of thing. So, like, can we expect that concept will be straightforward in the upcoming sessions?
So I would say the concepts will be slightly abstract in the next few sessions, next few weeks, but it will be easier to understand as compared to the first few weeks, till week 5.
Okay, okay, okay,
Because in
sir.
the past weeks the things were got mixed up. What I thought that why what I've seen that we got less clarity about the topics. So
That's something that we have discussed at length, I think so, in the last couple of live sessions, and I'll just reiterate what I've mentioned before, that it's just time and practice that are going to help you get clearer in some of these concepts. And it's okay to have ambiguity in the first few attempts. Everyone faces that. That is a constant for all students, no matter how good or bad they are at the starting line. Okay, everyone faces some ambiguity. Just put in some more time and effort into these things, and I think with time it should get more comfortable. Yeah, that's all I'm going to say.
There is one request. I don't know whether it will be okay or not for you people. Well, we need the solved for the assignments because it will help further to get the things more clearer.
Yeah,
Yes.
this is again one other thing that we discussed in the previous live session, that it is something that is not in my hands, unfortunately.
Okay.
So for that, I would urge you to post this request in the discussion forum and ask request all of you. If most of you feel that
Because
that is
it
really
happens in
beneficial,
all the NPTEL courses that
can I
the
complete, please?
okay, yes,
Yeah.
please.
So what I was saying is that if most of the students really feel and they really convey this to the NPTEL team, they should make a change, right? As of now, the trend that we are following is that we ask the students to post partial solutions that they have on a discussion forum, and then the main TA, who is Bhaskar and Sir, he helps out understand where exactly is the problem happening. In previous versions of the course, there have been instances where the solutions to the graded assignments were also shared, but that has been discontinued. And if most of the students really request the NPTEL team to do that, I think they should reinstate that. But unfortunately, I can't do anything in that. For that, the students have to really write to the NPTEL team and request them to make the change. So unfortunately, my hands are tied, and I really urge you to use the discussion forum to convey your feedback to the, or the feedback responses as well, that the NPTEL team asks you to fill in every week, to convey this fact to the NPTEL team so that they can change things if they want to. Yeah, please continue.
No, I think that you have answered my queries.
Okay. Okay. If there's nothing else, then maybe we can close the session for today, and then let's meet next Tuesday.
Thank you, sir.
Thank you, sir.
Thank you.
Thanks
Thank you
all
very
for
much.
attending.
Thank you.